So for the do now, there are 3 questions. One of them is multiple choice, and so I said try it with no calculator. We're going to go through and talk about how we can solve without a calculator. You will get a calculator on the test on both parts just because we haven't been able to do enough practice with mental math for you to not have a calculator. So could you technically take the multiple choice part of the test without a calculator? Yes. Will I require you to? No. So number 1 says the solution is prepared by adding 50 milliliters of water to 50 milliliters of a 0.0001 molar solution of barium hydroxide at 25 degrees Celsius. Which of the following values is the best estimate of the pH of the new solution? So before we get into any of the calculations or any of the setups or anything, focus on the substance that you have here. Barium hydroxide. Hydroxide tells me that it's some sort of base. And if you look at the periodic table, barium is part of that lowercase b on the periodic table. Because lithium all the way down, and then calcium all the way down. So Ba2 plus with OH minus gives us a strong base. So if barium hydroxide is a strong base, we can actually eliminate some of these choices because we're focusing on the pH. Well, if this is a base, whether it's strong or weak, if it's a base, the pH should be above 7. So I'm going to eliminate A and B. Right off the bat, I can eliminate A and B. Now, at least I have a 50-50 chance of answering this question. So now we're going to focus on finding the pH based on what they tell us. So we have this strong base solution. It says that the solution is prepared by adding 50 milliliters of water to 50 milliliters of the solution. Adding water to a solution is a dilution. So by adding water to this solution, it's undergoing a dilution. So dilution formula is M1V1 equals M2V2. When you add water to something, you are diluting it. You are changing the molarity. Diluting is changing the molarity. So this 50 milliliters and this concentration, I'm going to put this in scientific notation to make it easier to work with. 1, 2, 3, 4. This is 1 times 10 to the negative 4th. So 1 times 10 to the negative 4th molar times 50 milliliters.
Morning.
Hi. Oh, class. Hi. I don't know. Here's me like, well, I didn't turn around. Okay. M2 is what we're solving for. We're solving for the new molarity after this base undergoes dilution. Now the V2 is where we have to be careful. Here's where we need to read the question carefully. 50 milliliters is added to 50 milliliters. So 50 plus 50 is 100 milliliters. Now we can solve for M2. Again, I'm going to show you how we can try to do this without a calculator. And it just says best estimate. So it doesn't have to be exact. So to solve for M2, I'm going to divide 100 over. Times 50. And so this is what it looks like. Usually we would plug this right into our calculator, but I'm going to simplify if I can. 50 goes into 100 2 times. Goes into it 2 times. Now we get into some scientific notation math. So when you're working with numbers and you need to use, or you need to calculate without a calculator, It really helps if you put all of your numbers into scientific notation. So this on the top is already in scientific notation, 1 times 10 to the negative 4th. 2 in scientific notation is 2 times 10 to the 0. Here's why I'm doing that like I am. When you're doing this without a calculator, you focus on the numbers in front of the multiplication sign. So 1 divided by 2 is 0.5. That's not, should be multiplication. All right, 0.5 is 1 divided by 2 times 10. And when you have exponents, you have negative 4 divided by 0. Now you're not dividing with your exponents, you're actually subtracting. Negative 4 minus 0, that's negative 4. So here's M2. Now that's not my answer. I'm just boxing it to make it easier for me to find. Here's the new molarity. All right, this is the molarity of barium hydroxide. I have some people that are like, if I know that like 1 times 10 to the negative 4th would just be 0.05, do I need to show, or 0.5, do I need to show this? No. I'm just trying to help with scientific notation without a calculator. Now, pH. All right, my goal is to find pH. Well, right now I'm dealing with the base. More importantly, I'm dealing with a strong base. By labeling this a strong base, that means when we look at the base itself, it's a single arrow. This base completely dissociates. This completely dissociates in water. It's a single arrow. So if I have 0.5 times 10 to the negative 4th molar, I have 0.5 times 10 to the negative 4th molar of Ba2 plus, I'm going to have twice as much OH minus. I'll have twice as much OH minus. If I multiply this by 2, you just multiply the 0.5 by 2. Here's my OH minus concentration, 1 times 10 to the negative 4th. Our OH minus concentration is 1 times 10 to the negative 4th. If I take the negative log of this, negative log of OH minus is POH. Now you look at this and you're like, how am I supposed to take a log without a calculator? Well, here's a little trick, and I'm going to show this on the next slide as well. When you take the negative log of something, log is base 10. So if you have a 1 in front as your coefficient, right, you have 1 times 10 to the something, your negative log is the positive value of that exponent. So if I want to take the negative log of 1 times 10 to the negative 4th, the answer is 4. So when you have 1 times 10 to the negative something, the value, the magnitude, the positive value of that exponent, that's your negative log. Now, notice what I just wrote here. This is POH. Because you might look at this and say, well, I just crossed out 4. Yeah, because it wants pH. Remember that pH plus POH equals 14. So if POH is 4, pH is 10. Now, something else, looking at this, could you have said, well, PaOH is a strong base, pH should be relatively high? That would be a very good guess, and you would have gotten it right. But they could have given 10 and 11, in which case the highest pH is not the right answer. We are going to do lots more of this, like mental math practice, especially as we get into reviewing, because now that we finally know that the test is like normal, and you don't get a calculator on the multiple choice, we will start practicing this more and more, looking at all of these tricks for doing math without a calculator. For your test, you will get a calculator. All right, you'll get the calculator on the whole thing. It won't be until we review that we start putting our calculators away and practicing with multiple choice. Any questions on number 1? Yeah.
With 0.5 times 10 to the negative 5 times.
Yes. Okay. Yeah. I left it like this just because I knew we were going to multiply by 2. But yeah, so when you have this, right, and it would be the same like if you had 36 times 10 to the negative second. Your scientific notation should always be like one number and then decimal places. If it's hard for you to think about which way to go, because sometimes it's hard for me to think about like, okay, if it's 18 times 10 to the something, which way do I move it? I did this on one of my answer keys. I took this and I put it in standard notation. So I was like, all right, 0.5, negative 4 means I'm making it smaller. 1, 2, 3, 4. And I filled it in like this. And then I put it back into scientific notation. Like, all right, so now to go back into scientific notation, 1, 2, 3, 4, 5. 5 times 10 to the negative 5th. And this works. It's easier for me to be able to see. If you know which way it goes, if you know that 0.5 times 10 to the negative 4th is 5 times 10 to the negative 5th, you're good. But this takes, just a little bit of time to kind of go back and forth. So number 2, this requires no calculations. Number 2 says rank the following 0.020 molar solutions of acids and bases from lowest pH to highest pH. So I'm going to rank them from lowest up here to highest. Now I want to just take a step back and think. The lowest pH represents which of the types of solutions? It's a low pH.
Acids.
Acids. Right? So the lowest pH is the one that we would say is most acidic. And the highest pH is the one that would be most basic. Now you might look at this and you say, well, how am I going to do this without calculations? Well, let's go through and label all of the substances. HCN. HCN is not one of the 7 strong acids. I know it's an acid because it starts with an H, but it's not one of the 7 strong, so it's a weak acid. NaOH, I know it's a base because it ends in OH. I look at the periodic table, I see that sodium is in the B on the periodic table. Sodium hydroxide is a strong base. Strontium hydroxide. Again, I know this is a base because of the OH. Look on your periodic table for strontium. Strontium is part of that B. So strontium hydroxide is also a strong base. And then HBr, that's one of your 7 strong acids. So now we've labeled these. Well, remember that the most acidic, because these are all the same concentration, we can directly compare their acidity or their basicity. So the most acidic one is going to be the strong acid. So HBr will be the lowest pH. The next lowest is still going to be an acid. Now we have a weak acid, so that's going to be the next. Now when we get to the bases, it's a little difficult because these are both strong bases. But remember that when you have strong bases, the more hydroxides it produces, the stronger the base is. So NaOH produces 1 OH minus. Strontium hydroxide, when we put it into water, produces 2 OH minus. So NaOH would have a 0.02 molar hydroxide concentration. Strontium hydroxide, because they're both strong bases, they both completely dissociate, Strontium hydroxide makes 2 OH minuses, so it would have a 0.04 molar concentration of OH minus. The more OH minus, the stronger the base. So we would actually have NaOH and then SrOH2. So the lowest pH is the one that's most acidic. We expect our strong acids to have the lowest pH. And then the highest pH is the one that is most basic. So because we had 2 strong bases here, the one that produced the most OH minus was the stronger base, a higher pH.
Is it possible that instead of SR, like if you got an atom strong enough to make that negligible, make it equal to NaOH? That makes sense.
With 2 hydroxides, you mean?
Yeah, like this.
So if this were negligible, you would still have the 2 OHs. So if you wanted to try to make the OH minus concentration equal to NaOH, you'd actually have to make this a weak base, but you have to make it a strong enough weak base that the OH minus concentration could potentially be equal.
Oh.
But all of the weak bases have such a low Kb value that we wouldn't actually see that happen. So we always are assuming the strong base will have a higher pH than a weak base.
Okay.
Even if it were, like if this were MgOH2, right? Magnesium actually is not part of the B on the periodic table. So MgOH2 is actually a weak base. MgOH2 would actually have a lower pH, and NaOH would have a higher pH.
Oh, okay.
Because even though it produces 2 OH minuses, it's still so weak that it exists mostly as MgOH2 and not OH minus.
Okay.
Yeah. And then the last question, and this is actually similar to one of the questions on mastering. I don't remember the exact number. Where you're looking at what happens if you're at a different temperature. Right? What happens to your value of H plus and OH minus and Kw if you are no longer at 25 degrees Celsius? So looking at number 3, it says the hydronium ion concentration of a solution at 50 degrees Celsius is 6.2 times 10 to the negative 8th molar. So I'm just going to write down what they gave me. I'm just going to write it up here so everyone can see it. Hydronium is H3O+. Remember that H3O+ and H+ are the same. If you were to write H+ instead, that's fine. 6.2 times 10 to the negative 8 molar. It says calculate the hydroxide ion concentration, OH minus, at this temperature. We're at 50 degrees Celsius. We're not at 25. They say the pKw is 13.262 at 50 degrees Celsius. Is this acidic or basic, and justify your answer? So we can still use the idea that H plus times OH minus equals Kw. However, this value of Kw is different. Right? This is no longer 1 times 10 to the negative 14th molar. Wait, not molar. 1 times 10 to the negative 14th, because we're not at 25 degrees Celsius. Instead, they gave us this pKw. We've been talking about this P in front and how they give us K values using the pKa or pKb or pKw. So if pKw is 13.262, you can actually find Kw. Just like if we have pH, we can find H+. So pKw, this P in front just means that you took the negative log of the variable. That's all it means. pH means you take the negative log of H+. POH means you take the negative log of OH. pKa means you take the negative log of Ka. So if I want to find Kw, I have to go backwards. So if you remember how we go backwards, we move the negative over, and then we have to do the inverse log to get rid of that logarithmic function. So kW is 10 to the negative 13.262. So our kW at this temperature is 5.47 times 10 to the negative 14. So as we increased temperature, we increased our value of K. So as we increased temperature, we increased kW. Now that we have kW, we can solve for H plus or OH minus. So I know that H plus is 6.2 times 10 to the negative 8. I'm solving for OH minus, and kW is 5.47 times 10 to the negative 14. So divide, do 5.47 e negative 14 divided by 6.2 e negative 8. OH minus is 8.823 times 10 to the negative 7th molar. 8.823 times 10 to the negative 7th molar. There's our OH minus concentration. Again, when you are no longer at 25 degrees Celsius, kW changes. They have to give you your value of kW. What this actually would mean if they gave us this pKW of 13.262, that actually means that pH plus pOH at 50 degrees Celsius would be 13.262. That pH plus pOH equals 14 is only if you're at 25 degrees Celsius. Now we assume we're at 25 unless they tell us otherwise, like in this problem. So now, is it acidic or basic? Justify our answer. So now we're looking at H plus versus OH minus. Look at the exponent. Negative 8 versus negative 7. Negative 7 is just greater. So we would say this is a basic solution. My justification is that the concentration of OH minus is greater than the concentration of H plus. So again, there's a question like this on mastering where they give you a different kW. So you're no longer at 25 degrees Celsius. Now what I want you to keep in mind is that no matter what the temperature is, 25 degrees, 50 degrees, 10 degrees, if it is neutral, if it's water, water is neutral. It does not matter what the kW is. Neutral is when H plus equals OH minus, or pH equals POH. Right? The neutral pH at this temperature is not 7. Because the definition of neutral is that H plus equals OH minus, or pH equals POH. So that'd be what, 6.63 or something like that. 6.631 would actually be neutral, this temperature. So just remember the definition of neutral is that H plus equals OH minus, or pH equals POH. All right, so I know there was a little bit longer of a do now, but I wanted to make sure we kind of went through all of these different types of questions. I want to just look at estimating. And again, I know I told you that you get a calculator, but I want to show you how you can use pH to estimate. College Board loves asking pH questions in the multiple choice. Now, they also love asking them in the free response. But in the multiple choice portion of the AP test, you won't have a calculator. So when we're looking at estimation, it's important to remember when we have a 1 in front of the scientific notation. So 1 times 10 to the negative 10. 1 times 10 to the negative 4. When we have a 1 in front of the scientific notation, we can actually just take the absolute value of the exponent. That gives us our pH. So pH is negative log of the concentration. If you have a 1 in front, take the positive number of the exponent, there's your answer. Now, if they give you a concentration that's not 1 times 10 to the something, and you have an actual number in front. So if the number in front of scientific notation is not a 1, that's when we estimate. Here's the best way to actually estimate. So if I want to take the negative log of 8.45 times 10 to the negative 10, if it were 1 times 10 to the negative 10, I would just say, okay, the pH is 10. If it's not a 1 in front, what we do is we take the exponent, the positive value of the exponent, and subtract 1. So the pH is somewhere between 9 and 10. That's just a way to estimate when you're looking at negative log of a concentration. So if you have a number in front that's not 1, you take the positive value of the exponent and you subtract 1. They're never going to ask you to do a full calculation. You know, what is the exact pH? If they do that, you're going to have a 1 times 10 to the negative something, and you just take the number, take the exponent. Otherwise, it'll say estimate. You know, it'll say, what's the range in the multiple choice? And it might say 9 to 10. Well, then if you look at this and you say, okay, well, here's a 10, subtract 1, it's 9 point something. So we'll come back to this as we get more into reviewing and we look at doing kind of the mental math. So just some info before we get into free response questions. I posted the quizzes from yesterday back into ZipGrade. I added private comments into Classroom. So if you look in Google Classroom, I had the private comment, and then I think I also put something in the stream for your guys' class. So if you didn't do as well as you wanted, and all the information is in the private comments and in the stream of Classroom, so just take a look at that. If you didn't do as well as you wanted, there is a retake that's being offered on Monday. So I know there's no school, but I picked 2 time slots based on our schedule because we're at school that day. 10:30 to 11 and 1:30 to 2 are the 2 time slots if you want to take the retake. The form, there's just a form to fill out so I know who wants to take it. I can send Google Meet links to everyone that way. If you have an issue with those time slots, either just send me a private comment on Classroom or send me a remind, something like that. But that way you can kind of use the weekend, work on mastering, review. Hopefully today helps as well. Look back at your old quiz. In ZipGrade, I released your quizzes. I put my answer key up as well, so you can look at the explanations. It's the better of the 2 scores. So if you got a 16 out of 20 and you're like, I made silly mistakes, like I want to take it again. And for some reason you don't do as well and you get like a 14 out of 20. Then the 16 would still go into Power School, right? There's no averaging or anything. If you got a 16 out of 20 the first time, you studied, you looked over everything, you got a 20 out of 20, it goes in Power School as a 20 out of 20. So it's truly like a retake, no averaging, nothing like that. But there is a form to fill out for that retake, so I can send you the Google Meet link. The acid-base test. So we've been done with new material, but the acid-base test is going to be Tuesday, Wednesday. It's going to be a little bit like the last test that we took, where it's not just one day you take the test, one day you're at home. So I put the schedule up here because it's going to kind of be all over the place for who's taking what. Only because Wednesday being a 2-hour delay, my 3-4 class is split. So I want to make sure those that are at home are taking the same thing. So Tuesday, you guys will be on Meet. You'll do the multiple choice. Wednesday, when you're in class, I know it's a 2-hour delay. It's still 40 minutes. You'll still have plenty of time, right? So when you guys are in class Wednesday, then you'll do free response. So whenever you're in class, you'll do free response. When you're at home, it'll be multiple choice. For those of you that are completely remote, you can see kind of what that looks like for you. So if you're completely virtual, Tuesday is free response, Wednesday is multiple choice. So that will be Tuesday, Wednesday. Best ways to review. First and foremost, just look over your notes packet. All right, look back through your notes packet. I'm not saying watch all the videos again, but just look through your notes. I always type extra information in there. Pages 20 and 21 are the what you need to know pages of the notes. The very last 2 pages of the notes have the what you need to know from the AP curriculum, so you can read through that. We'll go through the free response questions today. Whatever we don't get done, those will be good ways to practice. A lot of it is weak acids, weak bases, percent ionization, things like that. And then the Unit 7 practice quiz, that's the review that was on the side counter. That has multiple choice and some free response questions as well. And then the video explanations for those are posted on the website. Mastering is due Tuesday morning, so obviously mastering is a good way to help your review as well. Remember that in your notes, we tried to label all of the questions in mastering that match up to our examples that we did. There were a lot that matched up. And then if you need to go back, and you're like, okay, we did example 8. I didn't get example 8 written down. All of the in-class practice and examples were recorded, and they're posted to the practice playlist. So that's linked in Google Classroom under the Unit 7 materials. Or if you just search my name on YouTube, it should pop up too. Because I post them each day. So like today, I'll be posting the stuff too. So if it's easier just to I think you can subscribe and get a notification as well. But that's up to you. So that's just kind of some general info. As I'm getting the breakout rooms set up for the free response questions, you can turn in your do now. So I made sure that the assignment for the do now was up and ready to go. You guys will get do now sheets next week when you're actually here. We don't even need a do now sheet until next Thursday, but I'll make sure that you guys have one next week. These free response questions, numbers 1 through 9, we're going to see how many we can get through, but 1 through 9 are all great questions to be able to review. 10 and 11 are extra free response questions. Some of it is no longer tested, which is why I just made them extra. But 1 through 9 are all very good practice. So whatever we don't get to, you can always work through those as well. What we're going to do is we're going to actually work through a couple at a time. You'll notice that number 2 on the front page is multiple choice. So I'm going to actually have you guys work through numbers 1 and 2. So you're working through the front page. Now, if you want to try to do number 2 without a calculator, you can, but remember that you guys will get calculators on the entire thing. So number 1 should take about 10 minutes. Number 2, since it's multiple choice, should be 1.5 minutes, so I'm just going to give you 2 minutes. So we're going to go ahead and look at the answers to numbers 1 and 2. So number 1, you had propanoic acid. They give you the Ka value. A and B are asking questions about propanoic acid, so the expression, and then calculate pH. Notice how I labeled propanoic acid. I said it's a weak acid, so we need to use an ice table. Let me zoom in a little bit more. So since propanoic acid is a weak acid, we had to use an ice table. So down here, now it looks different, like my answer key looks different from your guys's because you used to have to answer the free response questions on lines like this. This is the first year. It was supposed to be last year, but we didn't have an actual AP test. It was all online. This year now it's going to look like the free response that I gave you. So you're going to actually have space to answer after each part. So for part A, the Ka expression is the concentration of the products over reactants. Remember, you never include water. Ka and Kb expressions must be in concentration, so you need those brackets. Part B, because it wanted pH, we use an ice table. So when they give you the concentration of an acid, right, or a base, When they give you the concentration of that substance, that is the initial concentration. So initially, we have the propanoic acid. We have 0 of the ions. That's all they gave us. So we need to use X's. If we needed to find pH, the point of this ice table is so that we can find H+. As we find plus, take the negative log to get the pH. So we need to solve for the X value. We assume X is small. We get 2.725 for the pH. That makes sense. It's below 7. It's an acid. Part C. So if we come up to part C, now it says the methanoate ion reacts with water to form methanoic acid and hydroxide ion. So I wrote right here, so the methanoate ion is a weak base. If HCO2 minus produces OH minus, like in this equilibrium, that tells us that this is a weak base. It accepts a proton. And then part C is asking about this equilibrium. So in part C, it says, given that at equilibrium, OH minus is this concentration in a 0.309 molar solution of sodium methanoate. Sodium is a spectator ion. If you notice, all of these equilibrium equations that we always are given are net ionic equations. Sodium is a spectator. It's never included. So that's the original concentration of the base. So if we take a look at part C, I have the ice table over here. So we have the initial concentration. We have the equilibrium concentrations, and they are the same. They're both 4.18 times 10 to the negative 6 because of their ratios. When you subtract, this is why when we say assume X is, notice when you subtract 4.18 times 10 to the negative 6 from 0.309, it's still 0.309. So we're making that assumption that X is so small, it's not affecting that initial concentration, and this actually proves that. When we solve for Kb, products over reactants, don't ever include water, you get 5.65 times 10 to the negative 11. That's Kb. Kb is the base dissociation constant. Base dissociation constant showing the equilibrium a weak base. And part 2 says calculate the Ka of methanoic acid. Well, methanoic acid is the conjugate acid of methanoate. They differ by 1 H+. Remember that for any conjugate acid-base pair, Ka times Kb equals Kw. That's on your equation sheet. For any conjugate acid-base pair, Ka times Kb equals Kw. You assume you're at 25 degrees Celsius unless it says otherwise, and you get Ka equal to 1.77 times 10 to the negative 4th. And then part D asks, which is the stronger acid, methanoic acid or propanoic acid? When you're comparing the strengths of weak acids, look at their Ka values. The larger the Ka value, the stronger the acid, because Ka is products over reactants. So I'm going to scroll up for just a second. Ka is products over reactants. The larger your Ka means you have more products. That means you have more ions. More of the acid has dissociated. That represents a strong acid. So we would answer this and say methanoic acid is the stronger acid because it has a larger Ka. A larger Ka means the acid ionizes more. That's the definition of an acid. So that's number 1. I will tell you that number 3, right, we can't even talk. We're going to skip over number 3 for now. It is almost identical to this. So if you want to make yourself a note, right, you can go back and try number 3 based on this. It's the exact same skills. Calculate Kb, look at Ka of the conjugate, things like that. But then number 2. So for number 2, this was a multiple choice question. Technically, multiple choice questions, you do not get a calculator. On all of our tests and quizzes, for now, you'll have a calculator. Once we start reviewing, that's when I will slowly try to teach you how to math a calculator. So this is hydroxyl amine. So remember that amines are weak bases. gives us the equilibrium, and it says estimate. So see, you can see exactly how this looks. This is how a multiple choice question would look. Estimate the pH range for a 0.1 molar solution of hydroxylamine, and they give us the Kb value. So if you're estimating the pH, right, you know at some point you're going to have to probably take the negative log of H plus, or because this is a base, we're going to have to focus on OH minus. So we need to set up an ice table. Whether it's a weak acid or a weak base, if you have to do any calculations, you set up an ice table, you fill in what you know. Well, you have X is 0.1 minus X. When you assume X is small, this is actually what you get for the Kb expression. So 9 times 10 to the negative 9 is Kb, X squared over 0.1. You can see how I did this without a calculator. I went through and tried to explain step by step what I did without a calculator. So you multiply the numbers in front of the multiplication. You add the exponents when you're multiplying scientific notation numbers. You get 9 times 10 to the negative 10th. And then to solve for X, you have to take the square root of both sides. Taking the square root is like taking it to the 1/2 power. So you actually take the square root of the number in front of scientific notation, so that's 3. And then when you have the two exponents right next to each other, you multiply those, negative 5. So when you take the negative log of 3 times 10 to the negative 5th, that's OH minus. Take the negative log of that, you're getting POH, which is about 4. Because if you want to do it without a calculator, you take the value of your exponent and subtract 1 because there's not a 1 in front. So it's about 4, so the pH is about 10. Now, if you did it with a calculator, you got the exact value. But this was without a calculator. This is how College Board showed how to do this question. So I showed, if you actually are looking at the answers, you'll see that for this and for the other multiple choice question, it's like my work and then how College Board did it as well. But again, you get the same thing. So that's 1 and 2. Any questions on 1 or 2? So I'm going to have you guys do 4 and 5. So if you flip to page 2, you're going to go to the bottom, relatively bottom of page 2. You're doing questions 4 and 5. So 4 is another multiple choice question. So you can see what these multiple choice questions look like. And then 5 goes on to page 3. So in terms of timing, about 2 minutes for question 4, about 8 minutes for question 5. So again, numbers 4 and 5 on the free response questions. So we're going to go over 4 and 5. Now, if you didn't finish number 5, that's okay. Like, you'll be able to see the answers, and you can always like go back and finish it if you need to. Number 4, when I say that multiple choice questions should take about 1.5 minutes, that is on average. You will have some multiple choice questions that will take you 30 seconds. You have some that are going to take you more time. For number 4, if you try doing this without a calculator, you can see I went in and I kind of gave like general hints for doing mental math without a calculator. As we review, like as we get into the AP test review, we will start doing practice questions without a calculator. So as we're reviewing all of these different topics and reviewing multiple choice questions, we'll review doing this mental math. So we'll go through how to do math with scientific notation, multiplying decimals, things like that. The biggest thing with number 4 is that you had to use percent ionization and kind of go backwards. Remember that percent ionization is not on the equation sheet, but you need to know it. I guarantee you'll see a percent ionization question on the test. Whether in the multiple choice or free response, you will see one, at least one. So percent ionization is the H plus concentration at equilibrium over the initial concentration of the acid times 100. They gave you the percent ionization and they gave you the initial concentration of the acid. So they said it ionized 3%. This 0.03 is 3% as a decimal. So you could have done 3 equals H plus over 0.2 times 100 and solved that way. And then I started doing my math with scientific notation. Now, another trick when you're multiplying decimals is to just multiply the numbers themselves and then move over however many decimals you need. But the biggest thing with this is you end up getting an H plus concentration equal to 6 times 10 to the negative third molar. What's important to remember is that at equilibrium, that is also the concentration of the conjugate base, because they both start at 0 and they both change by the same amount because they're 1 to 1. So if that's H plus and the conjugate base, the problem wants you to find Ka. Ka is products over reactants. Now, I assumed that X was small and didn't play a part in the initial concentration. Also, it made my math easier. If you did 0.194 and you used a calculator, you still got an answer rounded to the same correct answer. But I was doing it all without a calculator. So you can see how I was multiplying my numbers, adding the exponents, how I divide numbers in scientific notation, and I get a Ka value of 1 times 10 to the negative fourth. So when you look, here's College Board's answer key. When you actually look at your answers, I know that some people were, they were doing the math and they got times 10 to the negative fourth, and so they immediately knew it was either A or B. And then when they did 1.8, that rounds up to 2. So the right answer is B. And then number 5. So number 5, let me see if there's any questions on meat. All right. So number 5 is more of kind of an interdisciplinary type of free response question where you have Lewis structures and bond angles. And we haven't talked about that in a while. Free response questions start to pull in topics that we've already talked about. So on the AP test, you're not just going to have a free response question on kinetics or just a free response question on acid base. It's going to pull in different topics. So part A wanted you to fill in and complete the Lewis structure. So when you complete the Lewis structure, remember hydrogens can only have single bonds. Carbon always wants 4 bonds. And then, oxygen, you have to figure out, is it going to double bond, have lone pairs? So you have to count your valence electrons. Part B wanted to know the bond angle around 3. The bond angle is based on how many atoms are bonded and how many lone pairs there are. 3 atoms bonded, 0 lone pairs, that's trigonal planar. The bond angle is 120. Then we get into the acid base. So part C says the pKa for lactic acid is 3.86. So notice how they're giving you these pKa values or pKw values. So if the pKa is 3.86, part 1 says calculate Ka. Ka is just 10 to the negative pKa. Like H plus is 10 to the negative pH. It's 1.4 times 10 to the negative fourth. Remember, once you solve for something, you're probably going to use that later. If you missed part 1 or you just made up a number, but you used that in part 2, you still could have gotten the part 2 credit. It says determine the pH for a 0.2 molar solution of lactic acid. Notice how a lot of these are having you determine the pH of a weak acid or a weak base. So it's a really good skill to have. You're going to use an ice table. So notice how College Board used rice. It's the same thing as an ice table, just have the reaction. Initial concentration, they used A's instead of X's to represent that it's an acid. Ignored water because it's a liquid. So for Ka, you have X times X on the top, initial concentration on the bottom because we assumed X is small. When we solve for H plus, we get 5.3 times 10 to the negative third. Take the negative log, you get 2.28 for your pH. Your pH should be less than 7. It's an acid. And then part D, would a 0.2 molar solution of propanoic acid be predicted to have pH that is lower than, equal to, or higher than lactic acid? Justify your answer. So your question or your answer, your response, needs to start with higher than, lower than, or equal to. So we're comparing propanoic to lactic. So a 0.2 molar solution of propanoic acid would have a pH that is higher than the lactic acid solution. And then when we're justifying our answer, we can say that propanoic acid has a smaller value of Ka, meaning it's a weaker acid. Weaker acids would have less H plus and for higher H. All right, because the larger the Ka, the stronger the acid, the more H plus it produces in solution, and the lower the pH. Well, if you're looking for the opposite, a lower Ka means it's a weaker acid, doesn't produce as much H plus, doesn't have as low of a pH. So in that case, right, we're comparing the Ka, and then we have to apply it to strengths of acids and what that means about pH. Any questions on number 5? Okay, so just like we get to 3, we also will not get to 6 and 7. If you want to make yourself a note, again, 3, 6, and 7 are all going to be very good review. Right? Especially number 6 because it has percent ionization. So look at 3, 6, and 7 at some point, and 8 as well, right? 8's a weak base. We're not going to get to that one. We're going to look at number 9. All right, I'm going to give you guys 7 minutes for number 9. It's just A, B, and C. So we're going to do 7 minutes for number 9. This was actually off of the test in 2018, so 3 years ago. So I'm going to give you guys 7 minutes, and then we'll go over the right answers for this one. So what we're going to do is we're going to go over number 9, and then, like I said, the ones that we did not get to. So 3, 6, 7, and 8 will all be very good practice. 3 is going to be a little bit longer of a question, so give yourself maybe, if you want to practice timing, 10 minutes. 6, 7, and 8 are all only 2 parts. You can probably give yourself 4 or 5 minutes for each of those. But I would recommend, like, the 2 things you want practice, these for your response questions, I really was trying to focus on the weak calculations. So this question, number 9, this was from the 2018 test. It says HF, the ionization of HF is represented by this equation above. In a 0.035 molar HF solution, the percent ionization is 13%. HF is a weak acid. Always label everything. Label that this is a weak acid. Plus, you know, because it exists at equilibrium. It ionizes a decent amount for a weak acid, but it's still weak. So part A, you have 2 particle diagrams for the ionization of HF. It says, explain why the representation in figure 1 is more accurate than figure 2. So here we have figure 1. You're going to notice we have mostly HF molecules. Figure 2, we have no HF. It's completely ionized. So this actually shows you the scoring guidelines for this question because it's a more recent question. So HF is a weak acid, so it only partially ionizes. Figure 1 shows only partial ionization of HF. Or you could say figure 2 cannot represent HF because it shows 100% ionization. So that was just 1 point. Part B, use the percent ionization to calculate Ka. So we looked at this before, right? We looked at this in number 4, the multiple choice question. So we have percent ionization is H plus at equilibrium over the initial concentration of the acid equals 0.13. That's 13% as a decimal. You solve for H plus, you get 0.00455. When you look at your ice table, you can completely fill it in to get this equilibrium row. And when you have that equilibrium row, you can plug it in, you can solve for Ka. So this was awarded 2 points. 1 for calculating H plus from percent ionization. That was one of the points. And the other point came from calculating Ka. So notice it says consistent with H plus. If you calculated H plus wrong, but you did the second part right, you still could have gotten one of the points.
If we assume that X is small, did we miss that?
No. No, if you wrote like assume X is small and then you did it, then you would still be okay. Yeah. And then finally part C, so the last part, this was just 1 point. It's talking about adding distilled water to HF. So you're diluting HF. Will percent ionization increase, decrease, or remain the same? Justify your answer. So percent ionization would increase. The percent ionization of a weak acid increases when the concentration decreases. So doubling the volume decreases the initial concentration. You can think about it as Q versus K, or you can just talk through it. You can kind of talk through the calculation, or you could show the calculation. But when you have a decrease in percent ionization, or when you have a decrease in concentration, you're actually going to have more ions.